Hello and welcome, guys. We are in 9.4 now, dealing with polygons in the coordinate plane, and we wanted to start here looking at these formulas because these are the so important formulas for this chapter. We're going to start by applying the distance formula, then we'll work through with the midpoint and the slope formula to look at how we can classify shapes. So big thing that we're going to start with is using my distance formula here, which really talks about the distance between the x's squared plus the distance between the y's squared, and then we take the square root of that because essentially this is a manipulation of the Pythagorean theorem. This is like your hypotenuse, so your hypotenuse distance will equal the square root of the sum of the other two sides squared, or the sum of the legs squared. So, hopefully you've already worked through the Pearson Module 1 up until the got it, but our got it question here has these points for a triangle, and it's asking, is the triangle scalene, isosceles, or equilateral? So we want to know, does it have no sides equal, two sides equal, or all three sides equal? So to find the distance from D to E, we use the distance formula using our x's and our y's. So I'm going to color code some things. Go ahead, try to start this, pause the video, and see what you can do on your own. So if we work through this problem here, because I wrote this as DE, D is going to be my point 1 and E is going to be my point 2. So when we talk about x1 and x2, so this will be my x2 minus my x1. So that's my 1 minus 0 here. This will be my y2 minus my y1 right there. I do the math and I see I get 1 plus 16, so I get the radical or the square root of 17. So DE has a length of radical 17. Go ahead and try the same thing for EF, and then for FD, or you can do DF. Order does not really matter. So for EF, here's where you start to see that order is somewhat irrelevant as long as we're careful with our math. We go from 5 to 1, or from 1 to 5, so we say 5 minus 1. Then we go from 4 to 2, so we say 2 minus 4. So we set that up. I get a negative value, but remember that when we square anything negative, it just becomes positive. So I have 4 squared plus a negative 2 squared, which gives me 16 plus 4, or a radical 20. This right now tells me that we can go ahead and say this will not be equilateral, but it could still be isosceles if my final side comes out to be radical 17 or radical 20. So especially if you cheated and just waited and watched me do these, then pause the video, do this on your own, figure out the length of FD or DF. You can go whichever order you want, but you need to figure out the length of that side. So pause the video now. So when I plug in my values, I decide to make my D my point 1 and my F my point 2 so that I can have 5 minus 0 and 2 minus 0. So I get positive values in there of 5 and 2. When I square those, I get 25 and 4, so I get a total length of radical 29, which then gives me 3 different lengths for my triangle. So I see that that also cannot be isosceles, so it turns into a scalene triangle is what we find out. Now practice trying numbers 1 and 2, but what's convenient about when we see the graph of the sides of the triangle, I can actually make those little triangles and I can see what those changes are right here. So AC, I can measure AC just because it's on the coordinate grid vertically, but to deal with AB, I see that this has a change in Y of 1 and a change in X of 4, so I can use that to my advantage. As well here, a change in X from B to C of 4, and then a change in the Y of 3. So we can split it up and find each of these as the hypotenuse of a right triangle. So essentially the distance formula that I can use here, similar to the distance formula that was right up top, is the change in X squared plus the change in Y squared. Remember, those triangles means the change in, and that's all this is finding up here. X2 minus X1, that's the change in X. Y2 minus Y1, that's the change in Y. So I come down here and look at the math. We can just measure and see that AC is 4. AB has and here I wrote it change in Y first and change in X second. So I get radical 17. Here for BC, I did change in X was 4 and change in Y was 3. Again, the sign of the change doesn't really matter because even if it was negative, we would square it and it would become positive. So we get radical 25 or just 5, and since I have side lengths of 4, radical 17, and 5, this triangle is in fact a scalene triangle. Try number 2 if you have not yet. I wanted to show out AB just to remind us of how we want to write these things. My change in x and my change in y are both 2. So I just have 2 squared plus 2 squared under the radical, which gives me radical 8. Now I think about the factors of 8 and ask myself, is there a perfect square involved? Well, there is. 4 is a perfect square, so we go ahead and rewrite 8 as 4 times 2. And then that 4 we can factor out or pull out or take the square root, and we get 2, radical 2, as my length for AB. And I did not show the work, but you could do the change in y and the change in x's to find out that BC and AC are both radical 34, which then makes this triangle, what type of triangle? That is correct, it is an isosceles. So our triangle here becomes isosceles, and our triangle number 1 was scalene. So here we're told that shape LMNP is a parallelogram, but what we're asked is to determine if something is a rhombus. So hopefully you've worked through problem 2 on Pearson and worked through their module of proving that something is a parallelogram. Here we have to prove that it is a rhombus. Now a rhombus, the only difference between a rhombus and a parallelogram is that a rhombus also has to have all sides that are equal. So in order to determine if all of our sides are equal, we need to look at what's the length of LM, what's the length of MN, what's the length of NP, and what is the length of PL. So you want to use your distance formula to check the distances of all of those, and then come back to determine if it is in fact a rhombus. So to save the time, because writing it out on the computer is getting very time consuming, here is my change in x, change in y for DE. We do the same thing for EF and the same thing for FD. And that got it that I just showed you was actually for the previous got it that we all solved together. This is actually not a got it. This is just one of the extra practice problems. So if you look at the distance from L to M and M to N and N to P, and you do the math, you get that all of their distances are equal to radical 5. So what we see is it is a rhombus. Now you may need to go back and do some reviewing because the next section that we're dealing with is classifying a quadrilateral. So you want to work through the Pearson module, but remind yourself, and you might need to go Google to remember everything, what makes a parallelogram, what makes a kite, what makes a rhombus, what makes a rectangle. How are all these parallelograms classified? What specific do I need to know? What about their slopes? Do I need to know anything about that? And what about the angles in which they meet each other? What about the lengths of the different sides, how they have to be relative? So make sure that you remind yourself of all of those details. So now we need to use our midpoint formula, which is back here on that first page that we started with. So our midpoint formula is essentially finding the average of the x's and the average of the y's. So hopefully you looked through the Pearson module and saw how it works on there. If we come to our got it problem here, we have an isosceles triangle, or an isosceles trapezoid. Now isosceles, you know, two sides of the same length. Trapezoid has vertices A, B, C, D here given to us. So what special quadrilateral? So we're being asked to determine what is it beyond being a trapezoid. Is formed by the midpoints of side A, B, C, D. So when I think about a trapezoid and the midpoints of that trapezoid, well, I first have to find the midpoints. So to do that, we have to find the midpoints between A and B, between B and C, between C and D, and between D and A. So I average out the x's and the y's for all of these, and I find my new points. So we're calling this a new quadrilateral, PQRS, with these points of 1, 2, 4, 4, 7, 2, and 4, 0. Now, if you have not done the midpoint formula on your own, you want to make sure that you're able to, because this is rather hard if you've not done it on your own. So then we scroll down and we see that they use the distance formulas to check between P and Q, between Q and R, between R and S, and then likewise between S and P. And because all of these are radical 13, that then tells me that this is in fact a rhombus. Now we're just going to look at number 6 here because number 5, hopefully you'll be able to do that on your own. Number 6 here, I don't actually need the midpoint formula for 2 of my midpoints. Between J and K, I can already figure out there's a midpoint right here between the positive 2 and the negative 2. And because M is at -4 and L is at +4, I see also that there's a midpoint right here actually falling at the origin. So now what I need to know is the midpoint from K to L and the midpoint from J to M. So we want to look at those two situations. So I will look at KL and find the midpoint of those, and then I will look at JM and find the midpoint of those. So go ahead, pause the video, try to find those midpoints for each of those, and you can name the points however you would like. So when I set out my midpoint formula for A, which I've chosen to call this point over here A, I use J and M. So I grab the x's, -2, -4, add them together, give me -6, then divided by 2 gives me a -3. I grab the y's, the 4 and the 0, add them together, that gives me 4, divided by 2 gives me just 2. I could do similar math for C, and I get that it's at +3, +2, and then I can connect all of these and I can check their distances, and what we actually see is this shape, ABCD, is actually a rhombus. So that is all I really have for you guys today. Please make sure that all of this makes sense and that you have those formulas written down somewhere that it's in your face and you're not going to be able to forget them. Our slope formula should be very familiar to you. You should be good at that by now, and distance and midpoint be working to get better. Please let me know if you have any questions, comments, or concerns.